Welcome to Study Loop.
Problem number 16 is a pretty interesting one. We are told that we have a particle of mass m and charge q moving in a circular path in a magnetic field, which I'll draw. Let's say it's going into the page or something. And we want to show that its kinetic energy is proportional to r squared. So the square of this radius. And there's part B as well, but we will get there in a second. So for part A, if we think back, there is an example, 20-6, that gives the radius of rotation as mass times velocity over charge times magnetic field. And by rearranging this, you can see that your velocity is related to the radius, the charge, magnetic field, and the mass of whatever this is. But kinetic energy is 1/2 mv squared. But if we plug in here, we can see that our kinetic energy is 1/2 m r3b over m squared. And one of these masses will cancel. And thus, we can see that our kinetic energy is r squared, q squared, b squared, all over 2m. So that's the kinetic energy, which shows that the kinetic energy is in fact proportional to r squared, which is what we were asked to find. But we can move on to part B, which asks us to show that the angular momentum is qbr squared around the center of the circle. To do part B, we need to recall that the angular momentum of a particle moving in a circular path is simply mvr for whatever radius that is. And we have an expression for v already that we can just plug in here. So we can get that our angular momentum is mrqb over m. The m's cancel. And finally, we get qbr squared, which, if we check, yes, that is what we were supposed to find. So part A and part B.